Now what happens if we have more than one onion layer, so to speak? We have functions buried inside functions buried inside functions. Well, fortunately, even though this looks daunting, the process doesn't change at all. I'm going to color code this by layers, and in this case I'll end up using 3 different layers. Our outside layer is sine, our first inside layer is cosine, and our innermost layer, we'll put in green here, is x squared. So what I have to do is I just have to differentiate from the outside in. So let's start with our sine layer. Derivative of sine is cosine, and I got to leave the inside of it alone. So that would be cosine of x squared. Now I'm in the white layer mode. The derivative of cosine is a negative sine. So I'm going to multiply this by a negative sine. And I got to leave the inside of that alone, x squared. Now I'm in green land. The derivative of the innermost layer, which was x squared, the derivative of that is just 2x. And so that is my overall derivative, y prime being that. The derivative of the outside layer, and I left the inside alone. Then the derivative of the, I guess the middle layer, you could think of middle. And I left the innermost layer alone. And then the derivative of the innermost layer, innermost. So I just work my way in. And you can have an infinite number of layers. Each layer that you have to start with, you should end up with kind of a product in your answer. So you can think of this again as an onion. Differentiating the outside layers in.